Welcome back. This is for the homework exercise 2. We are given that the drawing density function is equals to b and x with the power of 2 plus y with the power of 2 is equal or smaller than 1. Firstly, we are going to find b so that this drawing function is a valid probability density function. For the first question, we could say it's kind of easy, or I think it could be difficult for some students, since you need to imagine a figure here. Let me draw a figure. If you can't come up with this figure, I think it's kind of difficult for you. So wait a second, please. This is the drawing density function and x and y here. So since x with the power of 2 plus y with the power of 2 is smaller than or equal to 1, so the figure of x and y should be a circle, right? And the radius of this circle is 1, so here is -1, -1 here, and the drawing density function is always equals to a specific value, so there should be another circle here. It's a little bit so the figure of this drawing density function is like a cylinder with the bottom of circle, and its radius is equals to 1, and its height is equals to b. Here it is b. So this volume of this cylinder is equals to b times the area of the bottom, that is pi times the radius with the power of 2. So this is the volume of this cylinder, and equals to 1. So y is 1 here. 1 is that besides this volume, the density function is equals to 0, and so the integration of this joint function is equals to 1 if the point is inside this cylinder, so the volume of this cylinder should equals to 1. Yeah, this is the definition. So by solving this, b is equals to 1 over pi. Yeah, here. For the second question, it led us to calculate a bunch of expected value. So the first one, we are going to find the expected value of x. We could directly solving this by using the joint density function. That is the x and another integral, the b is equals to 1 over pi. That is x times the joint density function, so 1 over pi dy. And since the limit of x and y are a circle, so the upper limit is 1, 1. The lower limit is minus. Oh, sorry. For the y's limit is 1 minus x with the power of 2, and we take the root for the left and right, and y is equals to this. and the upper limit is the square root of 1 minus x with the power of 2. For the lower limit, we take the negative value of that, right? So this is the formula of this question, and solving this, the expected value of x is equals to 0. So basing on this, we could know that the expected value of x assuming y and x assuming random variable y, they are all 0, right? Since expected value of x is already 0 and they are all 0 under all the conditions. So what the difference is, these two here. The first one is that the lowercase y here is a specific value. So basing on the random variable y is equals to this small y, this specific value, this conditional expected value is equals to 0. But here the capital Y stands for the random variable, that is for the value of this y. So they are different. And basing on this metric, so the expected value of y and these two lowercase x, they are all 0. Since the expression of expected value of y is the same as x, so it is also 0 here, and we know this is 0, so these two are also 0. And it's reasonable, right? Since xy's figure is a circle, and yeah, they are same. Yeah, I think I don't need further explanation for that. And the last one is to calculate the expected value of xy. We could also take the definition of expected value. We just take xy times the joint density function. This is the definition, and we take the lower bound and upper bound here. We could so that this is equals to 0 as well. On the third question, it lets us to prove x and y are uncorrelated or not. From the last question, we get the expected value of x and the expected value of y, they are all equals to 0. And also the expected value of x times y is also 0. So this is equals to ex times ey. So that is the definition of uncorrelated. So x and y are uncorrelated here. I think that's enough for this question. Thank you.